Now, the whole idea of probability is taking a part and putting it over a whole and saying how likely is something to happen. If you remember in probability, the chance that something's always going to happen is like 100% if you talk about percent, right? And it's a decimal, though. How do we write 100%? We write it as 1, okay? 1 is the whole deal, and it shows up in math a lot of times, even when you're doing some different types of word problems, 1 can represent the whole thing. So this is what we're kind of looking at. We know when we have probability, it should be 0 all the way up to 1, somewhere in between, but it can't be bigger than 1. There is mathematically no such thing as 110%, give me 110%. Mathematically not really possible, but we know what we mean when we say that. All right, so what we're going to do here, if you look at the problem here, it says find the probability that a point chosen randomly inside the circle is not in the trapezoid. So it's not that we want it to land in the trapezoid, we want it outside the trapezoid. So if we're thinking about that part, the whole, wouldn't that be the part outside? Never good when I mess up. Part outside the trapezoid. That's the part I want. I'm going to need to sit down, I think, to do this because it's not going to let me. Let me just sit. It's the part outside the trapezoid, but inside the circle. I want to know what part of the area that is to the whole area. So if I can find what I could do is this. If I could find the whole area of the circle, which they actually put a space for us to do that, they're kind of leading us along here. And if I could find the area of the trapezoid, the part outside of the circle would be the whole minus the trapezoid, wouldn't it? If you think about it. And then how we could find how much is outside the trapezoid. That makes sense? If I wanted the area in the trapezoid, I would say the part of the trapezoid over the whole area of the circle. But since I want the part outside the trapezoid, I'll take the whole and I'll subtract the trapezoid to find out how much area I could actually hit with the target since I want stuff outside the trapezoid. So basically all you're doing is you're calculating these areas and then you're just going to make fractions out of them, okay? So let's find the area of the circle. What is the radius of the circle and how do you know? If this is the center of the circle, wouldn't that be a radius? What number does that hit? 5, okay? So my radius is 5 on this circle. So if I'm calculating the whole area of the circle, the area of the circle would just be pi r squared, wouldn't it, if I write the formula down? And that's just, still not picking up. That'd be r squared would be 5 squared. So that's just going to be 25 pi. Let's use that whole amount when we make our fraction just so it's as accurate as it could be, okay? So we're going to say, if I'm going to make a part the whole fraction, and again, I'm going to want my calculator here in a minute. I know what my whole area is here. My whole circle is 25 pi, so I already could go ahead and put that on the bottom. That's part of what I'm going to use to calculate my probability in a minute. Chance that I'll hit one of those squares outside that trapezoid, but within the circle. Now, if I want to find what's outside the trapezoid, that'd be a weird area to calculate. So what I could do is use this idea of composite area. I could say, take the circle minus the trapezoid. That would be what's left. It'd be kind of like the shaded area. They could have asked me what's the probability of hitting in the shaded area, and I could shade everything around that trapezoid, but not inside of it. It's really the same type problem we've been working. It's just that they worded it weird. They could ask us, they could have said shaded area here, and we could have shaded it in. So let's find out what the area of the trapezoid is. We know the formula is 1/2, and then we add the two bases, and we multiply by the height. It's not coming out real well here. So how are we going to find the bases here and the height? Just count it off, right? It's on a graph, and it's got little blocks there. So let's start with the top of that trapezoid. I'll kind of highlight in different colors. How long is this piece right here? Y'all count it off.
6.
Let's see.
Well,
One.
it says, it says 1, 2, 3, 4, 5, but it counts by 2.
Oh, we do have to be careful, don't we? You're right. You're right. Okay. So that's a tricky thing about this graph is that it's actually every block represents a half, doesn't it? So if there's six squares, each square represents a half. If you look, when they count, here's 0, right? Here's what she's saying. 1 is here. It takes 2 blocks to make 1. So if we got 6 blocks, that's really just, instead of 6, it's really 3, right? She's right. So this is 3. That's one of the bases. I'll stick it in here. I need to add it to the other base. How long is this base here that I just highlighted? It goes from 3 to -3, doesn't it? So,
Would you count that as a -3?
okay, they just situated it on a, what we're doing basically is counting the blocks. They situated it where it's, kind of in the negative and positive. I would just kind of look at it as counting how many blocks there are. Yeah, it's the easiest way to answer that. So, from 3 to -3, that would be 6 units long, right? If you counted the blocks, there's probably 12 blocks there, right? Everybody count 12? That would really be just 6 though, right? Because each block represents a half, so 12 blocks would be half 12 is 6. So that's going to be 6. And then our height, couldn't we calculate our height just by going straight up and down from the highest point to the lowest point? So how tall is that? That goes from -1 up to 2, right? So they go from -1 to 2. So from -1 to 2, from 2 to 0 would be 2. From 0 to -1 would be another. So it would be 3, wouldn't it? There should be 6 blocks there, in other words. So let's see, we can figure this area, this trapezoid out. It was a little tricky just because of the way the graph was numbered. So that's a half of 9 times 3. Come on, pick up. 1/2 of 9 times 3. That's 27. Golly, it is just not, it's not picking up. A half of 9 times 3 would be a half of 27. Let me just write that. Thank you, good. Not a good day for the stylus. 13.5. Okay. So that's the area. Can't even read it. It's so hard to get this thing to cooperate sometimes. That's a 13.5 right here. So if you're listening to the video, you're just going to have to listen to know that's 13.5 because you sure can't read it and there's not a lot I can do about it. Okay, so now how am I going to figure out the area? Do I want to put 13.5 over 25 pi? Wouldn't that be what it would be to hit inside the trapezoid, right? So I want to subtract 13.5 from 25 pi. I could do this. I could put it on the top and just write it that way, 25 pi minus 13.5. And you could put that in your calculator in one whole line, and it'll figure it out for you without you having to go do the subtraction on top and write it down, and then figure out the bottom and write it down and divide it out. You could literally just type in your calculator, and I'll write this in kind of green over here. If you go just to your regular old home page, not the y equal, you could type in parentheses 25 and then hit seconds, and then the up arrow is how you get the pi on the graphing calculator. You can actually get the pi to show up there. And you don't even have to put times in the middle. It knows that if you stick it together like that, that it's multiplying. And then you could subtract 13.5, put your parentheses, and then put a divide sign. And on the bottom, I would go ahead and put 25 pi in parentheses just because the calculator might think you wanted to divide by 25 and then multiply by pi if you don't put the parentheses there. So I'd put the whole top in parentheses and the whole bottom in parentheses. Has anybody got the answer for that? Anybody done that in their calculator? Okay. So I plugged it in the calculator and I got 0.83, and so we would choose B. I'll hit this. They could have asked this question in a more familiar way. They could have shaded all this in out here and say, what's the probability that a point chosen randomly will hit in the shaded area? And you would have it probably wouldn't have been so hard to understand. The way they worded it made it kind of weird, but it's just the whole area. Take out the trapezoid would be the part you're hoping to hit. If this were a dartboard and you were throwing a dart, you'd be hoping to hit in a yellow shaded area. So it would be the circle minus the trapezoid over the whole circle, because the whole thing is the whole circle.